Yes. Okay, hello. Hopefully everybody on the stream can see me here, and you should get the full monitor capture and the little picture-in-picture, which I apologize for. So here we're looking at a blank Unity scene, and I'm just going to go over some basic interface stuff. This is going to be pretty kind of high-level overview. So on the left is the hierarchy. This is where everything that you have in the current scene will be shown. You could have multiple scenes loaded potentially. So right now we just have the sample scene that Unity comes in with and 2 game objects loaded in the current hierarchy. When you select one of those game objects, the inspector will be populated with all of the components that object is currently carrying. Everything that inherits from mono behavior is going to come with a transform here. That carries your position, rotation, and scale. Position and scale are vector 3 structs, and rotation is actually a quaternion that's being shown as a vector 3 for convenience in the editor. If you want to know more about working with quaternions, go to someone smarter than me. I'm just kidding, I'll still help you with it, but quaternions are notoriously confusing. For the camera object, we have the camera component and an audio listener. When you add additional cameras, Unity will complain at you in the console about having multiple audio listeners, which will affect performance. So just make sure that you remove that audio listener on any subsequent cameras that you add. So every component has some number of exposed fields, including ones that you create. So you can change stuff in the editor or at runtime, and all of these components are available to the animator as well, which I'll be talking about in a subsequent session later. So if I select the directional light, we can see that the inspector changes what's being shown to a transform in light component, which is all we have for the directional light in this case. Down at the bottom here is the project pane. These are all of the assets that you've imported or created in the project. So that'll contain scripts, textures, sprites, 3D models, animation components, animation controllers, anything that you create over the course of your project. And then down here are the packages that have currently been imported. So fairly recently, I think in the 2017 release, Unity abstracted a lot of components away from the default install. So if you need, let's say you start in the 3D paradigm, but you actually want to make a 2D game, that's fine. There's not really a huge functional difference. But if you go to Window and Package Manager, these are all of the packages that Unity sort of offers by default. You can also import your own or pull them in from the asset store. But all of the tools that you might have expected to see in Unity, if you maybe used it in Unity 5 or the early 2017 cycle, are hidden in here. So like the 2D animation stuff. Now, one thing that's quite cool is that if you go to Advanced and Show Preview Packages, there's a bunch of stuff in here that's not maybe release ready, but is quite cool, like the 2D IK package, so inverse kinematics, 2D animation, you can do your own rigging and stuff all in engine. And then one other major one that I want to highlight is Pro Builder. So if you don't have a 3D modeling application and you want to do some 3D modeling, Pro Builder can do that in editor and can be modified at runtime if you access the right API calls. If you want to do that, let me know. But Pro Builder is a great package for that kind of in-app manipulation stuff. So we're looking here at the scene view. Moving around the scene view is pretty standard for most 3D interface applications. So your middle mouse wheel is going to scroll you in and out. If you select an object and want to focus on it, you can press F, and that should center it in your view. Rotating around, so if you hold Alt, it's going to orbit about the center. If you middle mouse click, that's your pan. But just remember that any changes in position you make in the scene view are not reflective of the game view. So if we click on the game window, this is the position of the camera, right? So you can see our camera here. If I were to create an object and put it in front of the camera, we can see it populate. You can see how the camera is actually going to be viewing that object. If you have the camera selected, you'll get a preview of that down here. Now, any components that you add will also appear in this component in the inspector here. And components include scripts. So let's say that we want a simple camera control script. There are multiple ways to create a script. This is my preferred way. You just go to add component, type the class name you want, and then create an add. You can double click either in this window or on this script down here. We could also create a script from there. So C# script. But let's crack open camera controls. So there are multiple ways to get a variable to appear in the inspector. The quickest and dirtiest way is to use the keyword public, which of course renders the variable public to other classes. But if we wanted to say have a public float called speed, we can default that float to some number. I'm going to default it to 5 here. And now when we select our main camera, we should see that the speed is accessible in the editor. Now you don't have to use that public tag if you want to maintain the privacy of the variable. You can use the serialized field tag. And now you retain the privacy of that float, but it's still going to be populated and editable at runtime here. Now any changes you make in the inspector are going to override the script settings, so it doesn't matter now that speed is defaulted to 5. It's going to be 12 when you run the application. So that is a default. If you're going to add that script to multiple components, it will come in at 5. I'm going to talk a little bit about input handling. So let's take a look at the project settings tab. Now any of these windows can be docked and moved around and resized. But if we look at the input and drop this axes panel, you can see that we have a bunch of predefined inputs here. So horizontal and vertical are mapped. Whoa. All right. Come on. Okay. Horizontal and vertical are mapped by default. We have a negative button of left, that's the left arrow, right, that's the right arrow for the positive button, and we have alternative negative buttons of A and D. Okay, so if you want to do input calls, you should use this abstraction unless you're using the P300 tool. Now we've also got this cross mapped here, so we have horizontal defined ones here, and then again here, and we have joystick axes mapped to the same call. So if we say, if we look for input from horizontal, that's going to work instantly with our analog sticks as well as WASD and our arrow keys. So I'll just do a little bit of simple position manipulation, and then we'll call it good for this intro panel. So I'm going to try to keep this simple. I'll just do a left and right for now. And if you have further questions on how you might handle this, it can be a little bit more elegant than what I'm about to do. So if we say float horizontal and assign that to input.getAxis horizontal. An axis is always going to return a value from -1 to 1. So if I'm pressing left, it's going to be -1, and if I'm pressing right, it's going to be +1. And on an analog stick, it can be any decimal value in between. So let's just say that we want to move the position of our character left and right when we push the left or right arrow. Because we're inheriting from mono behavior, we can say, if we just use transform, that's going to be the transform of the object to which this script is attached. So if we say transform.position is equal to, we're going to do some interpolation because we want to make sure that this movement is consistent regardless of the frame rate. So if we say we're going to use vector3 dot, we can use lerp or we can use move towards. I prefer move towards in this instance because lerp is percentage based, and you'll get kind of an ease in, ease out, kind of a slow, fast, and then slow again on the other end effect. But move towards will be an even movement from the position to the target position. So we're going to move from transform position to transform position plus horizontal, and we're going to do that at time.delta time multiplied by speed. So time.delta time, oh, right, new vector3, 0, 0. So we're going to take our horizontal float and treat it as the x value of our position modification, and we don't want to do any modification on y or z. We're going to move at this rate. So time.delta time is how long it has taken to get from the last frame to the current frame, and we're going to multiply that by speed so that regardless of the frame rate, we're always going to get that same basic movement effect. So having saved the script, let's go ahead and, so we're controlling the camera, that's fine. So we can now move right and left, and you can kind of see how you might expand that to include up and down, or in and out. So everything that you add to a game object will be populated here in the inspector and can be modified if you construct the script to allow that. I don't want to throw too much at you now, so are there any questions here in the audience or on stream for basic Unity interface stuff? Anything else you'd like to see covered now?
So there's one quick question. What is the difference between private and serialized field in terms of, you said you have public variables and then serialized field if you don't want it to be public? Can you explain the difference and why not using private there instead?
So all variables default to private. If I were to give the private keyword, then it's just kind of syntactic sugar at that point to remind me that that's a private variable. A serialized field tag on a variable that doesn't have that declaration it'll be a private variable.
So on that question, practice-wise, should we be making constructors, modifiers, that type of thing?
It depends on the use case. In most cases, no, you don't need to. But if you want to have, so one reason you might do that is if you have a UI component that you want to modify a float or an integer or whatever, you'll need a getter and setter constructor to allow access to that. Mm-hmm. Okay, so I'll be doing an animation workshop later, and let's see, what exactly is the timing on that?
It's set 11 originally.
I mean,
we can shift it until later because the...
Okay, so my understanding is that the Edmonton campus wants to participate in that, but won't be in until noon or so? Okay, so we'll kind of play that by ear as long as I want to make sure that everybody who wants these workshops is able to see them. So tentatively, we'll push the next workshops back a bit so that all of the campuses have access to them. All right, well, thanks for tuning in, guys, and I will see you soon.